for innovative food adaptation in cold and high altitude environments. The conference is also an opportunity to talk with the eminent and knowledgeable personalities, interact, connect, and learn. In order to obtain the certificate, the attendance is mandatory. Today we have strict orders that if the student marked his attendance in the morning session and found absent in the rest of the sessions, you are going to lose the certificate. So kindly stick to the attendance, please. Thank you. Proceeding forward, let's call upon our first speaker of the day. But before that, I would like to call upon the session chairpersons for the same. I would like to request Dr. Jayanendra Kumar, Professor and Principal, SRM Modinagar College of Pharmacy, SRM University, NCR Campus, Modinagar, Ghaziabad. Dr. Jayanendra Kumar sir has, his area of research is organic synthesis of compounds having anti-diabetic and anti-cancer activities, isolation and characterization of compounds from natural origin having diabetic and anti-cancer activities. He has total experience of 19 years and has achieved 20 publications, 10 patents, 2 book chapters, 1 book. He has also received 2 grants. He has also attended various workshops, national and international conferences. I kindly request Dr. Jayanendra sir to come on the stage and hold the session chair. The second session chair is Dr. Neeraj Kant Sharma sir, who is a principal of Department of Pharmacy, MIET, Meerut. His core area of research is phytochemical analysis of plant material, synthesis of heterocyclic compounds, molecular modeling, and drug design. He has total experience of 12 years. He has published a total of 28 papers with 5 patents and 1 book. He has actively participated in many national and international conferences. He is also a lifetime member of Association of Community Pharmacists in India. I request Dr. Neeraj Kant Sharma sir to kindly hold the session chair. I request Dr. Garima Garg ma'am to felicitate our session chairs with the bouquet. Thank you, ma'am. Thank you, sir. Now I would like to invite our speaker, Dr. Prabodh Chandra Sharma, sir, to join on the stage. Please, sir. I would like the session chairpersons to take the privilege and introduce about Dr. Prabodh Chandra sir and felicitate him with the bouquet. Thank you, sir. Yeah.
Very good morning to one and all present here. I would like to welcome Dr. Prabodh Chandra Sharma, to deliver his talk. Dr. Sharma is currently working as Associate Dean Academics at Delhi Pharmaceutical Sciences and Research University, that is in New Delhi. And he has about 135 publications to his credit in various reputed national and international journals. And he has presented about 20 papers in on various platforms, and he has a cumulative Thomson-Reuters journal impact factor is about 150, which is very rare. He has more than 5,300 citations to his credit, and as you can see that his H score is about 36 and item index is 79. We are honored to have him here. Dr. Sharma has outstanding achievement in, he has included in the list of top 2% scientists of the world because he has carried out a research at Stanford University in USA, that is consecutively for the 3 years. He was also selected for Researcher Link Scheme by British Council under the Newton and Baba University of York, that is in UK. And he was awarded for Fast Track Scheme for Young Scientists from DST. So, he is also head IIT cell at the University Meerut, and he has been an instrumental part to start a new programs at Meerut, such as MSc Artificial Intelligence in Medicine, Program Coordinator of BSc Biomedical Science at the University. He is a member of Board of Studies of Chaudhry Bansilal University, Bhiwani. He is a member of our Research Advisory Committee, that is JSS Academy of Higher Education, Mysore, and also a member and Research Advisor Committee, that is in the Central University of Tripura. So, having such a resource person, having such a good profile, and we are fortunate enough to have him here today. I would like to request Dr. Sharma, I would like to invite him and request him to deliver his talk, please.
Very good morning.
Good morning, sir.
Thank you so much for the nice introduction, and at the outset I would like to extend my thanks to the management and principal of this college, and especially to Professor Alok Sharma, who has been instrumental in inviting us here. I wish my greetings to all the distinguished faculty members, chairperson and co-chairperson of the session present over here, all the dear students, and one and all present here. The topic which is chosen for this conference, this program, is very apt, that application of AI in related to food and related to availability and arrangement of foods and its different aspects at high altitudes. And as far as food is concerned, microwave. So microwave is indeed associated with that, and there are very much advancements in this field also. So here, being one of the topics in the themes of this program is medicinal chemistry. So being a typical synthetic medicinal chemist, so I thought of correlating the things, and since I am working on the topic of microwave, so I felt that this topic is somewhat related to food, and since most of the students, as I have been told, are of undergraduate or PG level here, so the presentation or the talk will be primarily focused on the understanding of principles. So we will be not much focusing on the type of research that has been done in our laboratory. Rather, our emphasis would be to understand what microwave is and how it is applied, what is the basic principle behind it, and is there any difference in the traditional cooking method and the method of microwave? Is there any difference at the level of principle? So we will be focusing on that also. So with that, let us discuss a term, green chemistry. So my question to the students, what is green chemistry? Can chemistry be green? Any of you?
Yes, sir.
Yes. Any of you, please. Chemistry can be green or not? Have you heard of green chemistry?
Yes, sir.
Yeah, what is that?
In which we don't use the solvent. By using the water.
Fine, nice answer. So green can be two ways. Like you must have heard somewhere, electricity saved is electricity produced. आप जितनी इलेक्ट्रिसिटी को बचाओगे वो आपने प्रोड्यूस किया है, उतना ये मान लो. In the same manner, if we are able to reduce the hazardous nature of chemistry by one way or other, we are contributing to the environment, and that way we are contributing to make it green. So that way, what is green chemistry we'll be talking in brief, and how microwave is there and how it helps, that we will see. So the flow of the presentation would be like this. Let us have a brief look on the current scenario of pharmaceutical and chemical industry. So all of us must agree with the fact that there is an always increasing demand of consumer goods and pharmaceutical products. And due to this increasing demand, there is continuously a regular strain on the persons, on the scientists involved in this field. And you can see from here that the demand for pharmaceuticals and chemicals is continuously increasing. And for a country like India, for a country like us, where we are producing so many medicines, and many a times we are called pharmacy of the world, and generally second or third pill, whatever is taken in the world, that is produced in India. So you can assume, you can think the level of pressure the chemists and the pharmaceutical chemists are facing here. And the major gap area for the chemical industry is the traditional sources which are used for manufacture of these chemicals and drug substances are non-renewable, and their quantity is available up to a finite extent. And one day or other, the continuous exploitation of these substances will lead to depletion. And this exploitation is non-sustainable in nature, and day by day the availability of the resources is going to be scarce. And the other point which is very, very significant is that a huge amount of chemical waste is generated in the production of pharmaceutical substances. And waste is going to be a very, very big problem. And since you are here very close to Delhi, these scenes you can see almost in all the cities of the country. जब यहाँ से हम दिल्ली में एंटर भी करते हैं तो गाजीपुर के पास आप देखोगे लेफ्ट में बहुत सारे वल्चर्स आपको दिखाई देंगे आकाश में, and there is a big mountain.
Yes.
And not only from this border, you enter from Haryana side, Chandigarh road, on the Karnal bypass, again you will find a big mountain of the garbage. So this is really a very big challenge for all of us, and we can try to reduce in our own domains, and that's what we are doing for the synthesis of chemicals. So to fill all these gaps, green chemistry has been proposed. And what we do in green chemistry is, we prefer to use green solvents as suggested by one of the honorable audiences. The catalysts are green, the processes are made more efficient. What do you mean by the term more efficient? More efficient is simply that if you are reacting X with Y to produce Z, the percentage yield varies. The yield may be 50%, the yield may be 60%, and in some cases, yield may be 20 to 30%. So remaining 70% is a wastage, and that is going to environment. So we try to adopt methods which can lead to increase in the yield. So efficient processes are there, and ultimately the objective is to obtain environmentally benign products, and that leads to sustainable chemistry. To cater these needs,
Ritika.
the green chemistry has been provided with 12 principles. So there are 12 principles which include waste prevention, less hazardous chemicals, uh, reduce the derivatization, that is yet another field. And then safer solvents, design for degrade. There are some, like these 12 principles are there, and these
Sir, Gitika,
cater
rule number
to
5.
make environment more green, more clean through chemical aspects, through chemical approaches. And a term in chemistry which is very popular nowadays is circular economy. So what do you mean by the term circular economy? Students, what is
Ritika.
economy? All of us know. And circular economy? Economy in a loop, in a circle. So the traditional method, do you have a pointer? Yeah, thank you. So in the traditional method, this is the approach. Take the raw material, make something from there, use that, after use dispose the product and lead to pollution. So this is the traditional approach in chemistry. And now the circular economy involves you make something, use it, reuse, remake, then recycle, and then again make something from that. That is how China has done. Right? That is how we can proceed. So this is the typical circular economy model, and believe me, this has really been successful. I can cite one example of API, diclofenac, where for production of 1 kg of active API, there was generation of 1000 kg waste 25 years, 40 years back. But now that wastage has been reduced to 10 kg. So for production of 1 kg API of a drug, the waste generated is just 10 kg. So that way you are reducing the 990 kg of waste to the environment. And since you are reducing the waste, you are reducing the raw material also. And you are reducing the raw material, you are reducing the exploitation of natural resources. And that way you are contributing to keep the environment green. And that is what the green chemistry and circular economy is. So in circular economy of the chemistry, we have innovative products, and they are generally obtained from renewable feedstocks. Feedstock can be used from, and they can be obtained from some products. The processes and the products are designed to be reused and recycled. Feedstock is renewed through natural process, so that processing again saves the environment as compared to the other methods. And the product is increasingly treated as source equal to raw material. Moreover, ideally we feel that the role of chemist should be to create a world without wastage. So this is how circular economy works. And dear students, there is always an increasing enthusiasm, and this approach of green chemistry is getting popularized. This is one event that took place in University of Delhi, and subsequently many other events are there. And there is, yes, really very increasing enthusiasm among the young people, young chemists and pharmacists towards this approach. Now coming to microwave assisted synthesis. So this type of synthesis is a type of unconventional wet chemical approach. So as suggested, it is not only for dry, it is a wet chemical approach. And here the electromagnetic radiations interact with the matter, and with that interaction will lead to formation of or synthesis of the materials. There is importance of electromagnetic radiation. Electromagnetic radiation is employed for synthesis of the compounds. This technique caters many principles of green chemistry. As I said, 12 principles are there, but primarily these 5 principles: prevention of waste, less hazardous chemical synthesis with use of less hazardous chemicals and the solvents and reagents, energy efficiency. For example, if you go for a synthetic process in the conventional manner using RBF and the flask, the reaction may proceed for 24 hours or 48 hours. And the same reaction has been, that can be covered with microwaves within a time span of few minutes only.
Yes, sir.
And at the last, I'll give you some examples where the time required to carry out a reaction was varying from 8 to 10 hours or up to 24 hours. The same reaction could be completed within few minutes. So that way you are saving energy and water as well. And then atom economy is yet another term for enhanced percentage yield. And this is inherently safer chemistry for accident prevention. So what microwave is, as we know that these are a type of electromagnetic radiations. The spectrum is really very big, right from cosmic to X, gamma, UV, VG, and so many. So in this there is a range, it is just like any other electromagnetic radiation. So microwave is just like that, having the same properties, E is equal to h nu, which is hc upon lambda, and this is the region you can see here somewhere before IR and UV. This is the region where microwaves are used. For the information of students, just two types of vectors, electric and magnetic vector. Both are perpendicular to each other, and they are perpendicular to the direction of propagation of the radiation as well. What type of substances can react in microwave synthesis? What type of substances can be involved? So if the material is having some dipole moment, then the electric field component will interact, and that way the reaction will take place. And if the material is having some magnetic moment, then the magnetic vector of the field will interact, and that way the reaction. So anyway, there is going to be an interaction of the matter with radiation, and you are going to have your desired product. Here one interesting fact is that microwaves are non-ionizing radiations. और जनरली हम ये मान लेते हैं कि माइक्रोवेव की एनर्जी बहुत ज़्यादा है. किचन में भी माइक्रोवेव यूज होता है, स्वीट शॉप पे भी हमने देखा है. तो जनरली हम ये मान लेते हैं कि माइक्रोवेव की हीटिंग एनर्जी बहुत ज़्यादा है और उसकी वजह से वो हीटिंग जल्दी करके रिएक्शन को जल्दी कंप्लीट कर देता है. राइट, ये एक जनरल अजम्पशन है, और इसीलिए जो रिएक्शन है वो भी 20 घंटे की बजाय 10 मिनट में कंप्लीट हो रही है, क्योंकि माइक्रोवेव्स की एनर्जी ज़्यादा है. बट एक्चुअली दिस एनर्जी इज वेरी वेरी लेस. आप देख सकते हैं माइक्रोवेव की जो एनर्जी है दैट इज this much, 0.0016 volt. That means they are a very low energy radiation. और कोई बॉन्ड भी तोड़ना है, even for like energy required for breaking of even hydrogen bond, जो कि बहुत strong नहीं होता है, it is 0.21. And this energy associated with microwaves is much less than that also. So how does it expedite the chemical reaction? So it is clear now that these reactions are low energy radiations, and the energy available with these radiations are much below the energy required for breaking a chemical bond and for carrying out a chemical reaction. तो ये तो श्योर है कि माइक्रोवेव की एनर्जी की वजह से तो रिएक्शन नहीं हो रही है. Then how it happens? So these microwave radiations are not going to make or break any bond, but they are simply going to interact with the matter. They will excite or lift the potential energy of the molecule, and the energy barrier will be lowered considerably, and the heating effect does not come from melting or breaking of bond. कोई बॉन्ड नहीं टूट, बॉन्ड के टूटने की वजह से या हीटिंग की वजह से बॉन्ड नहीं टूट रहा है. ये टिपिकल माइक्रोवेव ओवन हमने देखा है. ये मैंने इसलिए एग्जांपल लिया है कि यहाँ पे कहाँ से आ रही है फिर वो एनर्जी, इतनी हीटिंग कहाँ से आ रही है. 1 मिनट में गुलाब जामुन गर्म हो जाता है 1.5 मिनट में. और आपने ऑब्जर्व किया होगा कि जब माइक्रोवेव की हीटिंग होती है तो कोर ऑफ द प्रोडक्ट इज सुपर हीटेड, होता है ना. और आप अगर शुरू में देखते हो उसको, अगर माइक्रोवेव में हीट होकर आया तो हम कुछ समोसा गुलाब जामुन करेंगे तो जल जाता है मुंह जनरली हमारा. इसका मतलब अंदर हीटिंग हुई है. ट्रेडिशनल में हम देखते हैं मिठाई या कुछ भी हो ऊपर से गर्म होगी, अंदर से वो इतनी गर्म नहीं होगी. So that is the actual difference in the principle. और एक ये परफोरेटेड बास्केट है, ये आपने देखी होगी माइक्रोवेव के, डोमेस्टिक माइक्रोवेव में भी होती है, जो कमर्शियल हम केमिकल सिंथेसिस के लिए यूज करते हैं उसमें ये नहीं होती, उसमें अलग स्ट्रक्चर है, शो यू कैसे होता है, बट डोमेस्टिक में ये होता है। सोचा ये जाली क्यों होती है? This perforated metal foil is placed so that the size of perforation is such that it is less than the wavelength of microwave. तो इतना रहेगा इसका पोर साइज परफोरेशन का कि माइक्रोवेव की वेवलेंथ से कम है, so that the microwave should not come out, but at the same time it gives you some visibility, so that what is happening inside that you can watch. So now let us see how this heating takes place. Perhaps the internet is not working, otherwise I was beginning to show you a small video. So what happens here, you can see this is a water molecule, okay, and when you apply microwave and due to electric field there will be movement in the molecule, it will move like this, you can see here, and this conversion from one vector to another vector is so fast that immediately the electric field will be inverted and the movement of molecule will be like this. So in the electric field, due to dipole rotation, dipole-dipole movement, the molecule which is present like this will start moving like this. Oscillate. All the molecules will be moving like this, there will be oscillation, and due to friction on the surface, a heat will be generated. And that is what the heating takes. That is how the heating takes place in microwave. So it is due to the, and here we compare the two types. When I did AMFORM's project also on the same topic, so when I joined, some of my senior colleagues suggested that भाई वही है ना, दाल बनानी है वो आपने गैस पे बना ली या वो आपने माइक्रोवेव में बना ली, हाउ डज इट मेक ए डिफरेंस? यील्ड के लिए भी बोलते थे यील्ड का कोई फर्क नहीं आना चाहिए, रिएक्शन तो वही हो रही है. इट वाज द फर्स्ट टिपिकल चैलेंज ऑफ द कन्वेंशनल केमिस्ट. लेकिन अब आप देखोगे सी हाउ डज हीटिंग टेक प्लेस इन द कन्वेंशनल मैनर. बाहर से हीट करेंगे हम, हीट करेंगे तो सबसे ज़्यादा हीटिंग होगी ऑन द वेसल. फिर उसके बाद जैसे जैसे यू गो डीप टू द कोर, the material will be comparatively less heated, and a gradient of temperature is generated over here, and there is no uniform heating. Gradient बनेगा तो byproduct की formation, right? Formation of byproducts, formation percentage yield of the product, and the quality of the product, that is going to be affected. But at the same time, if it is done in a microwave, heating is taking place in the core due to oscillatory motion of the molecules and due to their friction. So the core will be superheated as compared to the periphery, and this way there will be perfect interaction of the reactants and will lead to higher percentage yield and better product, cleaner product, and less byproduct as compared to the conventional method of synthesis. So this is the principle again depicted in the same manner. Conventional heating like this and microwave heating at the core, and that is why the temperature attained at the core in case of microwave is much higher as compared to the oil bath method. So reaction can be carried out in solution as well as in solid state. There can be apolar solvents used also, where we add some microwave susceptors. Then polar solvents can be used, and by using solid state there can be solid sport or neat reagents can be used. So that is technical part. And primarily the important factors are dielectric constant, dielectric loss and tangent loss. So here B-Form students are there, so I will be not talking much about. And these are the solvents. That this is how you are going to select a solvent for microwave synthesis. Now, three types of interaction of metals can take place. Three of the substance can take place. One is metals which reflect the radiation, and another are the solvents which will absorb and will provide a tendency for further reaction, and third is Teflon or parts which completely transmit. So when you are going to have a vessel for microwave synthesis, so this why we are talking about this is how to select a vessel to carry out microwave reaction. So this way, like substances which reflects, they are of no use for making such a vessel for microwave. Solvents are used for the purpose of solvent only, and such type of substances can be used for making the vessels. So these are some of the examples, like bombs or tubes or vessels. They are generally used for the purpose of synthesis or digestion in the microwave synthesizer. Advantages include reduction in time for synthesis, reduced number of side reactions, increased yield, improved purity, less use of solvents is required, increased density of films, and stereo selectivity. Yeah, there are different types of instruments available. Each one say multi-mode pe aaye, single mode. So for the synthetic chemical synthesis purpose, single mode instruments are commonly used, and for kitchens and domestic use, multi-mode instruments are generally employed. Autoclaves are, microwave autoclaves are used for digestion purpose. So this is a typical representation of instrument, and these are the commercially available microwave synthesizers. So one such product we are having in our laboratory, and these are some other models which are used. Now coming to the reality, around 20 years back, MIET published in 2003 that in the next 10 to 15 years, we will see a microwave reactor in every academic and industrial laboratory. It was expectation around 20 years back. And even some people suggested that they will become the Bunsen burner of 21st century. So this was what was actually expected, but the reality is not so. We do not find a microwave in most of the academic institutions. Any reason?
They are costly, sir.
They are costly. That is one big problem. And other problems of less popularity. सबसे पहली बात तो ये इंस्ट्रूमेंट ही 20 लाख रुपए का आएगा.
Yes.
Reactions with bumping, effervescence and colored reactions, it is a challenge, still is a challenge to carry out. Even open vessel reactions की भी problem थी, वो तो sort out हो गई है अपने instruments. Scale up बना लिया, माइक्रोवेव में आपने सिंथेसिस कर ली, लेकिन उसी को जब इंडस्ट्रियल स्केल पे प्रोड्यूस करना है, तो again that becomes a challenge. और सबसे बड़ा चैलेंज ये भी था कि जो हमारी ऑर्गेनिक केमिस्ट्री कम्युनिटी है, दे आर रेजिस्टेंट टू यूज. आज भी आप जाओगे ट्रेडिशनल, उनके पास जो भी हमारे के चाहिए क्या केमिस्ट्री में, कुछ ग्लासवेयर और कुछ सॉल्वेंट्स. सो टू चेंज द, जैसे व्हाई नोकिया वैनिश्ड, यू नो, सबसे बढ़िया जब व्हेन वी वर पीजी स्टूडेंट्स, तो नोकिया का सबसे बढ़िया फ़ोन चलता था 3315, 3310. आज कोई नोकिया का फ़ोन यूज़ नहीं कर रहे हैं. रीजन कि स्मार्टफोन पे जो ट्रांजिशन होना था वो रेजिस्टेंट थे कि नहीं हमारी टेक्नोलॉजी बढ़िया है, हमारे फ़ोन तो बहुत, इनको कोई रिप्लेस कर ही नहीं सकता है. एग्री. लेकिन स्मार्टफोन में सैमसंग और नोकिया के टाइम में भी एग्जांपल देते थे कि हु स्टार्टेड दिस सेल फोन, कौन सी कंपनी, मोटोरोला लेके आई थी सबसे पहले, और उसको नोकिया ने टेकअप कर दिया था. क्यों? क्योंकि मोटोरोला अपने मॉडल पे कॉन्फिडेंट थी कि हमारा, हम तो लेने वाले, वी आर द इनिशिएटर्स, बिगनर्स. तो ये कंजर्वेशन आता है, इससे नेचुरल प्रोसेस, मैं गलत नहीं कहूँगा उनको, वो भी ठीक है अपने पॉइंट पे, बट यस दिस रेजिस्टेंस, इसकी वजह से भी इतनी ज़्यादा पॉपुलरिटी टेक्निक की नहीं हो पाई है. बट इट डजंट मीन दैट दिस टेक्निक इज यूजलेस. हमें, because I am primarily addressing to the students, so you should have a broad view that इसका मतलब ये नहीं है कि यूजलेस है. Research interest is continuously increasing. You can see the number of publications in last कैसे कितना ज़्यादा रिसर्च हो रहा है, पब्लिकेशन का नंबर, एंड दीज आर द एक्चुअल एप्लीकेशंस, मेडिसिन केमिस्ट्री, प्रोसेस केमिस्ट्री, मटेरियल साइंस, synthesis of ligands, synthesis of natural products, heterocycles. These are the diverse applications and all the type of organic reactions. Alkylation, condensation, heterocycle synthesis, oxidation. Almost all type of organic reactions have been successfully accomplished in microwaves. And we are also working up to some extent. This is team working in our lab presently, and this is one new instrument. Already there was one more we have procured. This was one paper published where we could carry out a reaction of 3 to 4 hours in just 60 to 90 seconds. This is yet another example where microwave technique was employed for some traditional synthesis and to substitute a traditional synthesis. Yet another old paper, but very useful. Time reduction was much, like from 8 to 10 hours, it was reduced significantly. This is one more paper on green chemistry, although we didn't use microwave here, but we employed one chloramine T mediated synthesis. So it was very benign as far as environment is concerned. So this is yet another effort in contribution to green chemistry. This is yet another paper in the same domain. And anti-infective fluoroquinolone derivatives have also been, derivatives, not the drug, but the derivatives of fluoroquinolones have been synthesized. And because as I have been told, UG students are there, so I will not be much talking about research and how we did it. I'm just giving a general idea. And again, some recent publication related to green chemistry on thiazole-containing compounds for cancer therapy. This is not my work, but since I have been invited to this conference, so microwave versus conventional cooking of vegetables at high altitude. You can refer to this paper. Those who are really interested in the foods and microwave at high altitude. So this is one good paper, I could find it out. Generally, at high altitude, it is observed that boiling takes place at a lower temperature. With every 1000 meter, the boiling temperature reduces by 2 degrees for water, and similarly for other substances. तो क्या होगा उसमें, अगर ट्रेडिशनल हीटिंग भी आप कर रहे हो, बॉइलिंग जल्दी हो जाएगी, टेम्परेचर कम आएगा. So that way you have to adjust. And there are time हो गया मेरा 11 बजे का, so the suggested readings, if you are interested, this is one of the very good manual. Green chemistry teaching in this microwave induced reactions. ये आप चाहो तो those who are new, though chemistry teachers, you can take up some examples from here. आप कहोगे कि सर हमारे पास वो माइक्रोवेव सिंथेसाइजर नहीं है, तो इवन जो डोमेस्टिक माइक्रोवेव है उसमें भी कुछ मॉडिफिकेशन के साथ या कुछ रिएक्शन ऐसी है बिना मॉडिफिकेशन के भी आप ऐसा उसमें कैरी आउट कर सकते हैं. कंडेंसेशन और वो सब चाहिए तो उसमें उन्होंने बताया कि हाउ यू कैन कीप ए बीकर ऑफ वाटर and put some ice cubes on the petri dish, and then you can carry out the reaction using a conical flask in a traditional domestic microwave on also. Some reactions, I will not suggest all. This is yet another laboratory experiment using microwave heating. Yet another very good article. Those who are interested, they can further refer to this. So that's all. There is any question? I would
Sir.
be happy to. Yeah.
In microwave we used to have I have faced one problem, that while using the microwave we need pressure in that reaction, and due to pressure sometimes the vials blasters and all. So how can we do the method, because some are chemicals which are releasing so much of gases. So during that reactions, when we are doing that type of reactions in microwave, so what we can do?
I got your point. Yeah, you are right. And जब glass या quartz की vessels use करते हैं तो blast हो जाता है कई बार. It is there, इसीलिए जो एक मैंने दिखाया था यहाँ पे.
Same issue with exothermic reactions also.
Yes sir.
कुछ limitation है associated, but can see here.
Yes, sir.
Some options have come where they use the Teflon as the vessel for the reaction. और उसमें कुछ reactions जो blast है उसको avoid कर सकते हैं. It is there. लेकिन है ये प्रॉब्लम आती है और फिर उसके बाद जो वेसल क्लीन करने का काम है ना
वो बहुत
high
difficult
water
है.
वो फिर बहुत चैलेंजिंग हो जाता
Yes,
है
sir.
आपको सारा
Yes, sir.
प्रोसेस करना पड़ता है. Yes, limitations are there and research is going on in that direction, but you can try with the alternative reaction vessel. थोड़ा costly आएगा but हो रही है ये. Any other?
वेरी गुड मॉर्निंग सर. सर जैसे अभी आपने हमें माइक्रोवेव के बारे में बताया और आपने ये भी बताया कि उसकी एनर्जी भी काफ़ी लो होती है और मोस्ट ऑफ अस सर वी आर यूजिंग माइक्रोवेव इन अवर किचन सर, जो हम जल्दी से खाना बनाने के लिए गर्म करने के लिए यूज़ करते हैं. तो सर मैंने एडवांटेज तो देखे आपके स्लाइड्स में, पर कोई डिसएडवांटेजेस या कोई हार्मफुल इफेक्ट्स हैं हमारी हेल्थ पर, तो वो एक थोड़ा डाउट था सर उसको क्लियर करने के लिए.
Please sit down. माइक्रोवेव या कोई भी इलेक्ट्रोमैग्नेटिक रेडिएशन है उसके हार्मफुल इफेक्ट दे आर ऑलवेज इन डिबेट. ओके, एज फार एज रिपोर्टेड एंड साइंटिफिकली अप्रूव्ड इंफॉर्मेशन इज आई कैन टॉक अबाउट दैट ओनली. माइक्रोवेव जब घर में यूज करते हैं और उसके बाद कुछ सेकंड्स का टाइम होता है कि तब तक लाइट उसकी ऑन रहती है. डोंट हैव टू ओपन टिल दैट. उसके बाद ओपन करते हैं तो मानते हैं कि माइक्रोवेव इज जस्ट लाइक मोबाइल फोन है ना. मोबाइल फोन का भी बोलते हैं कि कोई नुकसान नहीं है, आप पढ़ लो मिनिस्ट्री ऑफ टेलीकॉम है या नहीं है वो हम सब समझ सकते हैं, अपनी अपनी परसेप्शन है. तो टेक्निकली तो मैं कहूँगा कि उस लाइट के बंद होने के बाद आप किचन में यूज़ करो नुकसान नहीं है.
Sir, फिर what about for food, sir?
Even I have a question because like you said in the like presentation, like there is no breakage of the bonds, but there is like in the
Oscillations.
Breakage of bond is
oscillations.
not due to the energy of microwave radiation impeding on the molecule. It is due to the heat generated due to oscillatory motion and friction of the surface of the molecule. उस heat की वजह से हो रहा है वो breaking of the bond.
so that means like the food is not affected by the radiations which are given from the microwave, or like when we are heating up, because everyone like it's also a kind of a debate which is going on, like the food which has been entered in the microwave, you should not eat it because it might hamper your like health.
देखो इस बात पे मैं इतना ही बोलूँगा. I can have a limited communication के अगर हमारी regulatory authorities फूड की अगर उसको डोमेस्टिक और किचन यूज के लिए अप्रूव कर रही है तो दे मस्ट हैव सर्टिफाइड इट, दे मस्ट हैव वेरीफाइड दैट. उससे ज़्यादा कुछ भी बोलना एट ए फॉर्मल प्लेटफॉर्म इट इज नॉट एडवाइजेबल. ये आपकी परसेप्शन है, आपकी इंडिविजुअल रीडिंग है, मैं इतना ही बोल पाऊंगा. राइट.
There isn't any formation of new bonds when this occurs.
रिएक्शन कर रहे हैं तो बॉन्ड फॉर्मेशन तो होगी. वही आंसर है कि ड्यू टू द एनर्जी ऑफ माइक्रोवेव वो जो हो रही हीट आ रही है. द पर्पस वाज दैट द हीट व्हिच इज जनरेटेड इज नॉट फ्रॉम द माइक्रोवेव, इट इज ड्यू टू द फ्रिक्शन और उस हीट से जो ब्रेकेज बॉन्ड हो रहा है. रिएक्शन है तो बॉन्ड फॉर्मेशन तो होगी सर. कैसे?
So still it is debatable whether it is very safe or not.
नो आई विल नॉट से दैट. अगर ये से डिबेट होती तो हमारी अथॉरिटीज उसको अलाउ नहीं करती. राइट. I cannot say that. अगर वो यूज हो रहा है तो एज ऑन डेट इट इज कंसीडर्ड टू बी सेफ एंड दैट्स व्हाई इट्स अलाउड इन द मार्केट.
Thank you.
मैम सर बॉन्ड ब्रेक हुए बिना ही बॉन्ड फॉर्मेशन हो रहा है.
मैडम अगेन के बॉन्ड माइक्रोवेव एनर्जी नॉट having that much energy that it can break or form a bond. It is just providing the energy to oscillate.
Right,
And
sir.
due to oscillation, friction is taking place.
Right, sir.
And due to friction, heat is generated.
Right.
And with that heat, the breakage of bonds is taking place.
Sir, sometimes in conventional method we are doing synthesis, so it used to take 20 hours. But when we use microwave, it used to take 6 to 7 hours.
Yes.
But can we reduce that 6 to 7 hours also to less time?
Reaction optimization you have to do. फिर वो अपनी जो ट्रेडिशनल नॉलेज ऑफ केमिस्ट्री रिएक्शन ऑप्टिमाइजेशन की आएगी. आपका क्या सॉल्वेंट है और वो सारी तो केमिस्ट्री वही है, केवल हीट देने का मेथड चेंज किया है हमने. ऑप्टिमाइजेशन करो हो जाएगा. एनी अदर क्वेश्चन?
Thank you, Dr. Pramod, for enlightening us on the microwave technique. My question is related with the theme. So actually, you have a brief about the scope of the microwave. I want to ask because we are from the pharma profession, and can you highlight how can this technique can be helpful for the armed forces who are living high altitude? Theme is not specific, not a food or not a pharma, but I would like to take home message from you. What will you suggest and what will your take home message for this theme? Thank you.
आलोक जब भी क्वेश्चन पूछता है, I'm always afraid of him. मैं भी बहुत क्वेश्चन पूछता था when we were in the same batch. Okay, so being my classmate and batchmate, I can take this liberty to talk about him in this way. Food, microwave, and high altitude for armed forces. Yeah. कल ही पढ़ा है मैंने इसके बारे में. Because I am not a person involved in the science, but I came to this conference, so I had to read about it.
I think we should ask them
Variations in the preparation of foods. Vegetables के केस में adjustment करनी पड़ेगी. जो high altitude पे बैठे हैं उनको अगर फूड बना के देना, no doubt microwave is going to help them. और immediate वहाँ पे तो सब चीज़ रेडीमेड चाहिए, है ना? We need पहली चीज़ इलेक्ट्रिसिटी चाहिए वहाँ पे हमें. अगर वो दे रहे हैं तो माइक्रोवेव वहाँ पे पहुँचाया जा सकता है. So that is first requirement. Equipment मिल ही जाएगा, कोई हमारे पास वो नहीं है resources की कमी. Now for vegetables adjustment is required. For meats no adjustment for microwave at high altitude or low altitude is required. And similarly, there are well-defined guidelines by the companies or the vendors of microwave for high altitude. तो वो गाइडलाइन फॉलो करनी पड़ेगी. मैंने कई सोर्सेज कल देखे to justify my role at this platform also for high altitude food. क्लियरली लिखा हुआ है, जो भी वेंडर्स हैं माइक्रोवेव के, उनकी जो मैनुअल है उसमें इंस्ट्रक्शंस है कि हाई एल्टीट्यूड पे जाके कैसे कैसे बनेगा. बट ये क्लियर है कि यूज़ वहाँ पे माइक्रोवेव का फॉर अर्ली एंड प्रोडक्शन ऑफ फूड एंड इन गुड क्वांटिटी, दे आर वेरी यूजफुल. ओके, थैंक यू.
Thank you. Thank you.
Thank you so much, sir. I would like to invite the session chairpersons, yes, please, to felicitate Dr. Prabodh. I would request now Dr. Alok Sharma sir to come up on the stage to felicitate our session chairs. Thank you so much, sir. Proceeding forward, let's call upon our next speaker for the day. And I would request Dr. Prabodh Sharma, sir, and the session chairpersons to kindly take the seats. Now, I would like to call upon the session chairs persons for the next session, Dr. Sudhir Chaudhary, Director, Saras College of Pharmacy, Bagpat. He is working as Professor and Director at Saras College of Pharmacy, Bagpat, since 2019, with more than 18 years of academic and 2 years of industrial experience. He has published a total of 10 papers with 5 patents and 1 book. He has actively participated in many national and international conferences. He also received several prizes in singing and sports competition. I request Dr. Sudhir Chaudhary, sir, to come up on the stage. Thank you so much, sir. I would like to request now the second chairperson, Dr. Niranjan Kaushik, sir, Professor, Galgotias University, Greater Noida. He is an M.Pharm, PhD, Pharmaceutical Chemistry. He is presently working as an HOD in the Department of Pharmacy, Galgotias University. He has total of 16 years of experience. He has published a number of papers with 5 patents, 2 books, 3 books